Welcome to GD Gear. Don't forget to subscribe and click on the bell button.
Hello everyone, welcome to GD Gyan. So before we go to the next slide, let's quickly look into my DB related question which I asked in my previous episode. Let's quickly look into all the 5 questions and their answers. How many relational DB engine RDS support? 6. We discussed that. Yes, we can use a Oracle existing license into AWS RDS. It's called bring your own license. Elastic Cache, we have option for backup. Yes, only for Redis. Memcached is the basic one. Data transfer between EC2 and RDS in same AZ is free. That's correct. It's free. IAM admin role can SSH and manage RDS server, though all the RDS are not serverless, but still we cannot do SSH. Thank you all. Let's go to the next one then. These miscellaneous services I'm going to cover, or I was planning to cover as part of my last episode of this entire course. However, the people whom I'm trying to train, uh, they have exams scheduled in the second week of June, so I'm planning to cover it as my next episode. And after this, we'll only leave networking part, which would be covered in 2 sessions. So these are the broad topic that I'm going to cover today. And at the bottom, we have a few bullet points in the green box. AWS migration tools, that definitely I'm going to cover, but it would be a different episode and that's not going to be part of your solution architect exam. And other things are given there. Let's go into the main slides. Snowball. The name looks like it should be ball made of snow, but it's not like that. It's an hardware appliance. Looks like your computer CPU, desktop CPU. You can see the picture over here, right? So it though look like a CPU, but it's much more heavier, much more wider than that. Why it is used? It used to collect data from your data center to AWS. So why we use such? So just to save our money and time. So it's been proven that the kind of size or for a long petabyte scale data, if you try to use normal internet speed or even the higher speed of internet, the time it takes, it is faster than using Snowball. So 3 types of snowballs are there. The normal snowball, which has a two types of capacity, 50 and 80 TB. Snowball Edge with 100 TB, and it comes with a compute unit. So it has a Kindle attached to it, and it has a compute unit, Lambda and other functions are there. So maybe you can use that as a small data center. Suppose you are flying, you do not have internet connectivity there, and you have Snowball Edge. It could be a storage, and you can have your own compute there. So it's a compute unit also, like that way you can think of. Snowmobile is a petabyte scale, looks like a truck. It's a petabyte scale data. If you want to transfer, you can use Snowmobile. How to do that? In AWS console, you go create a job. They will ship you this thing to you, and you copy your data to AWS Snowball and ship it back, and they will upload into S3. So it can happen import and export to S3, and it is secure. So just to understand, it's a hardware appliance to transfer data in a cost effective way, and it is easy, it is time saving, cost saving as well. Cloud front. So suppose I have multiple people across the globe accessing one bucket located in one region. So these all groups, when they're trying to access this bucket, right, they are taking longer time, right? So that's why this thing comes cloud front, content delivery network. So as the name suggests, it helps to deliver content with a faster timeline. So how that happens? Apart from availability zone or region, they have something called AWS have something called edge location. So you can see that it is a separate entity. It has edge location around the globe. So even though, suppose I am into a region, I am into India and Chennai, and I do not have my nearest region could be Mumbai, but I may have a nearest edge location much more near to that than my actual region. So it will find out a nearest edge location for you. It will cache the data, S3 data, into that edge location, and you would be accessing that from edge location. So here this picture, instead of going through directly to Amazon S3, I mean this one, we are going through CloudFront. So it makes data access easier. It's caching your data in near to your location into edge location. Let's go look into the current point that I have, which may be useful for your exam. So CDN, content delivery network, delivers web and media file. It's two type: web distribution and RTMP. RTMP for media, web distribution is definitely for web, be it static or dynamic. It has three important parts. So CloudFront consists of three important parts. One is definitely edge location, which is not a region or availability zone. Based upon my location, it would be a nearest location would be considered as edge location where AWS has that service. Origin, from where we are expecting the data. So origin could be your S3, which is your storage. EC2, load balancer, when multiple EC2 being managed by a load balancer. So load balancer also could be your origin. And cloud 53 for your DNS, when you are accessing something with the URL, alias name or CNAME, that is also your origin, right? So don't try to memorize this thing. You understand, you are either you are accessing a storage, public access storage, right, S3, either you are trying to access a VM, right? Either you're accessing the load balancer, right? Behind that you have EC2 instance and cloud 53 DNS. So, and the third one is the distribution. So which are the edge location it would be delivered? For example, I have one website which is mostly applicable for APAC, right? So I do not want my user from US, Canada, Europe, they should be accessing that. So I would find out all the edge location within the APAC region, and I'll make a distribution of that. So my content would be delivered to that. We discussed this 2 points. Edge locations are not only read only, it can be write also. We can write into that. So suppose the content from here getting coming to here in the edge location, we can even write, user can write into that. Okay, in case, so suppose I have one AWS course being kept under the S3, right? And in between the syllabus got changed, or they have new module in, but my previous course is already cached to all the edge, the distribution, right? All the distribution edge location. Now people are accessing the old module until this doesn't get removed uh, mm, by the edge location TTL policy, which we'll discuss in the next now. But so I wanted to delete those, so I can delete those content and I can have the new content to be there, but that is chargeable. So TTL is time to leave, which is a default option. So this content would be removed after a time to leave, right? While creation setup, you can control URL. So yeah, we can, I mean, when you are creating your CloudFront, you can have option to signed URL or signed cache option, so that also can ensure the security as well. Hope we understood Snowball and CloudFront. And quickly let's go into the website and let's check how it looks. So cloud CloudFront. So you can see it, Global Content Delivery Network. I just wanted to cover as much is going to come into your exam. So not to make you confused, you just understand the main points, and mostly your storage, network, compute are the one going to be your top, I mean your database as well. And this miscellaneous service, it's going to be your optional one. I mean there would be question, but what I'm going to cover in this section, that would be enough. So I'm just creating this thing, you see, web and RMTP. So this is part of it. Okay friends, let's go back to our PPT. Okay, now let's discuss about other few services. Storage gateway. So what is that? It's a service which you can download from AWS to your VM. But before that, what is storage gateway? So storage gateway is a service AWS provide which help you to connect your local data center to AWS. And you can synchronously, asynchronously, you can transfer your local data center data backed up to AWS. So if you don't wanted to migrate your application into cloud, but you wanted to be backed up those data into cloud, you can use storage gateway. Remember that it's a VM, you can download it into, so it supports your VMware ESXi host or Hyper-V Microsoft option. It has three types of thing. One is file gateway, which stores only the file on NFS port, right? Volume gateway is for the database or volume, like EBS kind of a thing. And volume gateway is also two types: stored volume. So understand this thing, you read this content also. Stored volume is something data stored on your on-prem. It get asynchronously backed up to S3, but people who are the application who are trying to access, they will access it through on-prem only. So data would be there into on-prem, it would be backed up into S3, right? Cached volume, as the name suggests, only the data frequently accessed would be at on-prem, and rest of the data will stay at S3 or backed up into AWS. Whenever they need the data, they will be retrieved and cached into your local volume. Tape gateway, so something you are trying to back up in your on-prem data center, you wanted to do it through AWS. You choose AWS gateway, storage gateway, and the service you choosing AWS tape gateway. So you are storing that into S3 and S3 to Glacial, right? So understand this thing, storage gateway, everything backs up. Even any service you have a backup, it is S3. So even though the volume gateway EBA is block based storage, but it is getting into S3 only. Coming back to, hope you understand the storage gateway, let's coming back to Athena and Misc. So Athena is a query. So this is a new service. So suppose I have AWS, all the data stored, and I wanted to run a query. How are the data? What are the data? What are the logs are of this data? I do not have any other tool available earlier. So Athena is a service by which you can consider S3 entire bucket list as a table, and you can run your query to get that, right? And it is being charged based upon your query and based upon your terabyte data scan, TB data scan, right? So Athena to query your S3 structure to understand that. Misc. Misc is one of the security protocol that AWS launched to protect your personal identifiable information. It works with the natural language and processing. It works on your CrowdTrail logs also. We'll discuss CrowdTrail also, but understand Athena is a query. Misc is to security or protect to your data. So it helps to protect your personal data, and it also works the logs, and it's a great tool for preventing. It has its own dashboard reporting and alerting as well. Understand CloudWatch and CloudTrail. So CloudWatch is AWS monitoring. It has feature like event alert dashboard and logs. So we understood this thing, right? Anything we are monitoring into AWS, it is done through CloudWatch. So I given a picture like CloudWatch is to monitoring, right? Like this one. So basic monitoring 5 minutes, which includes CPU, network, disk, right? It doesn't include memory though. Remember that, and status also, right? For your hypervisor and your system, you can go for the advanced monitoring, right? Which will chargeable, and it would be at 1 minute. So CloudWatch also have dashboard, logs, alert. We created the billing alarm, right, through CloudWatch. CloudTrail is audit service. So any call that is coming to AWS, any API call into the logs, that is your CloudTrail. So anybody who accessing your AWS service through any API call or trying to access anything, CloudTrail is logging, and that same log Misc could analyze as well. So if there is any personal identification information like SSN, your data, your address, your security details, that would be accessed and protected, prevented, and alerted as well by Misc. So understand this thing. There would be a lot of question on the CloudWatch and the CloudTrail. However, CloudWatch is to monitoring, so it's a performance monitor. CloudTrail is a detective who's actually watching somebody else footprint into your stuffs, into your AWS resource action. Hope we understand this thing. Next one is the EFS, Elastic File System. So it is like we discussed in the storage section that we have block based, we have object based, and we have file system data, file system storage, right? So S3 is object based, block based is the EBS, and EFS is a file system. So the main advantage, it grow and it shrink based upon your data. So if you uh, uh, have more data, it will grow. If you have less data, it will shrink. So it is fully managed by AWS. So, and multiple EC2 can connect to that EFS. So EFS, multiple EC2 have same storage. So any change is happening into one storage, you don't have to replicate, don't have to copy. Everything would be accessed by that, right? EFS also has a lifecycle policy based upon the date, and it supports NFS, right? File system. So it supports NFS port. So suppose whenever you are creating the EC2 instance, you have the security group. There you have to allow NFS port so that you can talk to your EFS instance. It support multi-AZ region, right? Within the region, and it has read after write consistency. So that means anything you write into EFS, you would be able to see it immediately. Hope you understand storage gateway and appliance to connect on-prem to AWS cloud and to take backup. Athena is to query S3. Messi is to understand the logs, prevent, protect, and report as well. CloudWatch to monitor your services. CloudTrail is to monitor uh, all the audit things. It all the logs, anybody accessing your database, accessing your API. That is, EFS is a different type of storage, which is a file system, which is can grow exponentially and based upon your requirement, and supports multiple EC2 access at the same time. Okay, friends, let's go to the next one then. Cloud formation. So right, cloud formation is a template. So suppose it's a template. I have one template. I'm launching two EC2 instance, one RDS instance with some Apache to be configured into that, and I want into this region, this is the VPC configuration, all those things, right? So I created a template and launch it, and anytime after that, if I deleted something, if I have a issue, or I wanted to change that thing, so I delete those resources, I change the template configuration, I'll relaunch. So it is a template by which you can launch a stack of resources, right? Complex architecture, instead of do it one by one, you configure one EC2 instance into one region, another into another region, then RDS, then their security group, their network access, NACL protocol, all those things, right? Instead of that, you create a template, you launch it, so, and you deliver it to the developer team or the group. So it is a template to launch a set of resources. So hope you understand the cloud formation. Placement group, it works for your EC2 instance. So it, at the name suggests, right, placement group is something which tells you that what are the EC2 instances, or how you are going to save your EC2 instances, right? So for example, mm, whether you wanted to keep all the EC2 instances in the same rack, right? Definitely within the same rack means same availability zone. So that's called your cluster. Whether you wanted to keep each of the EC2 instance into each of the rack to provide the fault tolerance in the same AG, so that in one rack, if power failure happens, hardware failure happens, your other application should be running, right? Partition is something, suppose you have one database, one application tier, both is one group. So you're keeping one group in one stack and another group into another stack, so that if you're giving fault tolerance but as a group. So cluster, spread, and partition, these three types of placement groups are there. Mainly it improves your network throughput, network performance, latency improves that, and fault tolerance as well. For cluster, definitely it is homogeneous. It cannot span multiple AZ, because you understand it's in the same availability zone, same rack actually, and other two can span multiple AG but within the same region, right? So placement group has a unique name within the same AWS account, and you cannot merge placement group, but you can move one instance from one placement group. So but it has to be stop state. So I think we understood this thing. WAF, Web Application Firewall. It's a firewall which runs on your 7th layer, which is application layer of the OSI model. So any traffic or HTTP, HTTPS traffic comes to your API, load balancer, CloudFront, or any of your instances, WAF or WAF control that. It can filter any particular IP based upon the origin, based upon the region, based upon the location, country. Any SQL injection is there, it can prevent that, or any type of query. For example, I'm trying to access a website called www.gdgan.com, and then name equals to ABC question mark, ID equals to 1010, like this, right? So these are the query strings, so we can protect that. So WAF is a great tool to protect your application, right? So understand this thing. Elastic transcoder, suppose I created a video, maybe this tutorial, I uploaded that into S3 bucket, I converted that through elastic transcoder, and it will convert that into different format, mobile format, Apple OS format, tablet format, desktop format, large TV format. So it helps to change the format into different for different devices. So that is what elastic transcoder is. Let's quickly go through this one. Cloud formation stack of resources through a one template. Placement group helps you to improve the network throughput, network performance, and helps you to reduce the latency. It tells you where you are going to keep your EC2 instance within the same data center. Cluster split and partitioned, right? Three types. WAF is your application layer, firewall protection. Elastic transcoder convert into media file into different device format. I have one small picture which will give you understanding. Okay, so let's understand these three things: SQS, SNS, and SWF. SQS is simple queue service, SNS is simple notification service, SWS is simple workflow. There would be a lot of question around this thing, around comparing this SQS, SNS, and SWF. SQS, so as the name suggests, queue, right? So it's a pull based service where you can have a message size of 256 KB, but you can grow much more than that. But in that case, the data would be stored into your S3 bucket. Retention is 1 minute to 14 days, and by default is 4 days. So understand this thing. So any message is coming to SQS, right? It will come and it will be accessed by some other EC2 instance, some other processing unit. It can be two types, right? Standard queue, which doesn't guarantee a order. So you have message received 1 2 3 4. So normally we have heard about FIFO, LIFO, all those things, right? But it doesn't guarantee your message sequence. So it would be going into 3 5 2 3 1, like that way. So once it is being received, then it will be deleted. So as this one doesn't guarantee your order, so it can be delivered multiple times, also duplicate also. So you have to choose your service where duplicate message is not an issue. For example, money transaction cannot be into your standard queue. For that, definitely you need a FIFO queue which guarantee that no duplicate delivery, and it supports group of message also. For example, you are sending a type financial messages into one group, and then other booking details into other group, like this way. But here we have a limitation. For standard queue we have unlimited transaction that we can send. For FIFO queue it's only 300 transaction that we can send per second. And so you need to understand, based upon the situation that you are going to get the message, understand this two topic: visibility timeout and long polling, right? So visibility timeout, which is maximum 12 hours, which means you have one message in standard queue or FIFO queue, and one of the EC2 instance got that. So EC2 instance started processing it, and in between that something happened and EC2 instance got stopped or got removed. So when your message being picked up by EC2 instance and processing is not complete, your message in the queue would be as a hidden state, right? It will not be visible to any other EC2 instance, and it will wait till the visibility timeout defined for that queue. In case the visibility timeout expired and still the message not processed and got deleted, so you would lose that message. So there would be question that message is being delivered to EC2 instance, but the message is not being processed. What should I do? You need to increase your visibility timeout so that message is being taken, it was started processing, it got stopped, and then again message will reappear in the queue, would be picked up by other EC2 instance. Understood this thing? Long polling. So your EC2 instance will poll to SQS to get the message, right? To get the what is being waiting in the SQS. Now it comes there, checks, nothing is there, it goes back. Again it comes, it goes back. But when it goes back, in between something has come and visibility timeout is less, it is getting deleted. So what happens? You need to do a long polling because the number of time EC2 will poll, they would be charged. So if you do ask EC2 instance, go there, wait for some time, long polling, and once the message comes back. So then your charges would be reduced and your failure chances would be also less. So understand this thing, SQS, anything they discuss about decoupling your architecture, decoupling your application, you go for SQS. There will be a lot of scenario based question on SQS, SNS and SWF. SNS, simple notification service. As like SQS, it's a notification, it sends you a message through push notification. SQS pull, SNS push. It comes to like SMS, email, or to any endpoint, right? It comes to our mobile. It works almost on all the operating system as well. So there is a topic which has a subscription. If you subscribe onto the topic, message comes to the topic and you would be getting that. So suppose we have a topic for my AWS account billing should not go more than $10. So that is a topic we have created. You remember at the very first session. Now, if it goes more than that, I would be getting an email to a particular email ID. That is my subscription. I have accepted the subscription. So if I want that subscription go to multiple endpoints, we can do that. It's supposed multi-AZ to prevent loss of your message because SNS has to be very fault tolerant. We cannot allow the SNS notification go deleted. So multi-AZ is enabled for that pay as you go mode. SWF is simple workflow. You go into Flipkart, you check some product, you buy, you click on the buy, then you select your payment method, you enter your address, and you place your order. And after that, it triggers a couple of things, right? Some of the task or the workflow. So this entire thing being managed by SWF. So any workflow that you wanted to create, it is SWF. So understand this thing. It has task, it has human involvement with the workflow. So if anything being comes that which one would be SQS or SWF. So if it is human involvement, then SWF. If it is decoupling kind of a word, it is SQS, right? If it is a task oriented, it is SWF. So that is what. So that kind of a question comes. SWF keeps track of end to end. So suppose if I place an order, until I get the product at my home, it would be a full monitoring. And but SQS, there is no monitoring. Nobody monitor whether your queue message got deleted or something. It is the application who needs to do that. SWF has three parts: activity starter, who starts the activity; activity decider, who decide what activity will be next; and activity workers, who will actually take care of the work activity. For example, activity starter is when we start by this one, right? Now decider, who decides that what would be next step, payment. So payment is the next step. Now once the payment is done and put the order, right? And now it is the worker, like people who will come put the merchandise division, they will do the logistics. So all those things, human or machine, all would be part of your SWF activity worker. SQS, pull based, SNS push based, SW task based, or human driven. Understand this thing. There would be question, lot of question comparing these two situations, right? Thank you. Let's go to the next one then. Elastic Beanstalk. It's part of our compute service. So which is like you have one which is like you don't have to know about AWS EC2 instance security group, any of the VPC or anything. You have one application, PHP application, let's assume, and you wanted to put it into AWS. How you're going to do that? You have Elastic Beanstalk, you upload your application there, select and upload and complete. So rest AWS will take care of everything. Though you don't have to select security group and other thing, it would be next steps kind of a thing, which will not ask you what is the port, all those things. It will ask you like menu driven option, like what is when you want this application to be enabled, and auto scaling, monitoring, load balancing, everything they would be taking care, right? So this was one of those very fastest service that AWS has launched initially. So understand that. So it's easy for one who don't know about this thing. ECR, it's a Docker container registry who maintain the images of Docker. So Docker, we all know it's a containerization service. So suppose you have one server where you wanted to you don't wanted to have 5 different server for 5 different operating system like AIX, Unix, Linux, Windows, or SUSE Unix or anything, right? So you have one server where you created separate container, and each container has their own flavor, own types of OS layer, own application architecture, application stacks, and you now wanted to deploy those application into that. So that's images. So those Docker images being managed by Elastic Container Registry, ECR. It's a fully managed. It is integrated with ECS, Elastic Container Services, which is the orchestration service. It is fully highly available, fully managed, integrated with all the IAM policy. ECS is also one of those fully managed orchestration service. Coming back to Lambda, very important topic, but no needs for any hands-on as of now. Just understand this thing. It is also one of those compute service, Lambda. It is serverless, like we have Aurora, like we have API gateway, like we have EFS. So all these things are your serverless services, right? So understand this thing. So Lambda is something, it's a function. It only get triggered based upon event. So we discuss something, some change in your EC2 bucket. Somebody uploaded a picture into EC3, S3. That picture you wanted to have a tagline. Now, as soon as you upload a picture into S3, it will trigger a Lambda function. Lambda function will do some processing, and it will add one tagline into that and upload into another S3 bucket. So it works on a trigger, and trigger could be your HTTP, your S3 API gateway, SNS, SQS, IIT, Kinesis, DynamoDB, load balancer, many other things. But understand, RDS cannot be a trigger. So you have lot of trigger option, but RDS is not that. 1 million requests is free. After that, points 0.20 USD per million requests. Is a very cheap. It supports Go, Python, Ruby, .NET, Java, PowerShell, a lot of different technology language by which you can write your function. So it's something, all the layer, like starting from your data center, hardware, operating system, application, all the components, everything being managed by AWS. You just have a page where you can write your function, what you want this to do, when it would be triggered, and it will start working. So it's very complex architecture which you don't need to understand, but in case you wanted to understand or debug something, you need one app which is called AWS X-Ray. You cannot do it by yourself. So understand this Lambda. So ECR, Elastic Beanstalk, Lambda all comes under your compute only. So that's why you kept here Elastic Beanstalk. The difference between Elastic Beanstalk and Lambda, Elastic Beanstalk is just to provisioning your EC2, but without knowing anything about cloud. It's anybody doing for the first time and don't wanted to learn cloud, they can do it using Elastic Beanstalk. ECR is a container registry where they can contain different Docker images, different types of Docker images. Lambda is a serverless service. It's a function where you can write something. It could be your compute also. For example, uh, uh, if I have a Dynamo, suppose example, one SNS notification came, and after that I triggered a Lambda. So based upon the notification, I want it process some set of services. So it will be doing that. So based upon the coding, which can be write into Go, Python, Ruby, C Sharp, Java, PowerShell. So this is it, guys. Let's go into the next one, and this is our last section, and after that I'll just cover 2-3 topic. API gateway, it's the endpoint. So suppose I have one lambda function. I cannot call it from outside, right? I Lambda function trigger would be any of the AWS service we discussed, right? S3, DynamoDB, IoT, Kinesis, right? So how I'll be triggering lambda function? So I need one service from external which can be triggered in a secure way. So API gateway is that. API gateway gives you an endpoint. The endpoint I click, endpoint will have this get pull, get put and post kind of HTTP RESTful access. It will trigger the lambda function. So it's not only trigger the lambda function, it can trigger EC2 instance, it can go into DynamoDB, but understand it's an endpoint which somebody from outside can trigger and access, or it's a gate to access your uh, services inside your AWS environment. It's a secure way of accessing it, right? Okay, now let's come to the Kinesis. Kinesis is something streaming data. So the data we get from the stock, tweet, sensor, or IoT sensor, or social media, right? So we discussed those kind of a data comes like a stream. So where they would be stored, how they would be processed. We know that DynamoDB could be used for storing those data, but in case they need some process or some storing mechanism, they cannot come directly to DynamoDB, right? So that is what Kinesis is used. They have three types: Kinesis Stream, Kinesis Firehose, Analytics. Kinesis Stream has a storage. You can store into shard between 24 hours to 7 days, and shard is like a block. So shard is like a box. So one Kinesis stream can have 5 shard, one for social media, one for tweets, one for stock market, one for IoT sensor, and each shard can hold data for 24 hours to 7 days, right? Kinesis Firehose is something they process it immediately. They have a lambda function in it. It cannot store it, and kinetic analysis could be your Kinesis stream or Firehose, but it has analysis process inbuilt. So it not only stored, it also process and analyze the data. So understand this Kinesis part. So question would be around that. If it's something mentioned about shard, it would be Kinesis stream. Something mentioned about lambda function, it would be Kinesis Firehose. Something mentioned about analytics, it would be Kinesis analytics. Understand this ENI, EFA. So ENI, Elastic Network Interface, which comes with your EC2 instance. We have seen when we have configured the EC2 instance at the beginning. So each network, one ENI card for that. ENA, Enhanced Networking, is for high throughput network, 10 gigabyte per second to 100 gigabyte per second. And EFA, Elastic Fabric Networking, for high performance, mostly for high performance computing or machine learning kind of stuffs. So that's what we cover everything here. Let me go back quickly to the first page. I mentioned AWS migration tool would be a separate topic which I cover later, which is not needed as part of this course. But understand what is the Elastic Cache and placement group. Placement group, placing your different EC2 instances into the data center together in one rack, one by one into different rack, group by into different rack, right? Where Elastic Cache is something web search. If somebody is trying to make the web query on a database faster, right? They wanted to keep the frequently queried data into Elastic Cache so that the query could be faster. So if anything comes from the network throughput or network fault tolerance in a data center without having multi-AZ on, you can go for placement group. It can improve your network latency, network throughput. But if somebody is asking about latency on the performance something, it will go to the Elastic Cache. How to connect on-prem and AWS cloud, I'll discuss that much more detailed way in next two session, in our networking session. But definitely during with the direct connect or BPC could be the option. We discussed lot of security protocol, right? One is definitely WAF and NACL. NACL we have not discussed yet, but NACL also helps to block IP address, where WAF definitely helps to block IP address content from a country, a particular query string. So when some malicious activity happens, it will not always happen through one IP, right? So you have to have multiple types of definition, which NACL is unable to do that. So where you need WAF, right, which works on your application layer at the very seventh layer, which could be attacked, right? So that's why you need web. So understand these two difference. AMI and cloud are the same. Lot of question I have seen in Google or lot of different forum. Cloud formation is a template where you can launch multiple instances. You can even include a AMI part of your cloud formation. AMI is just one EC2 instance or some configuration image which you can share. So it's a different thing, different purpose. I hope you all have understood this thing. Let's stay tuned for the next session, which we are going to cover networking part, mostly the Route 53 and VPC networking part. After this, we have a 30 minutes or 40-minute session on AWS migration techniques. So understand this solution architect course better and then understand the migration techniques.
Please like, subscribe, share. Thanks for watching.